Yes, good afternoon from the beautiful island of Mauritius. I see some of you in the chat saying good morning also. So good morning to you from the other side of Africa, and good evening to you if you are joining us from that part of the world also. You're all welcome. Um, Usual formalities before we start the workshop. I would like to know where you're joining us from. So if you can please go to menti.com and enter the code 85348214. Let me show that on the screen. So you can either scan the code with your phone, or all right. So enter the code 85348214. 67 of us responded. So and there are 53 of us in the room right now. Okay, that's a bit of a tip today. It's kind of balanced. 11 of us. Okay. So we have a huge turnout for this session from Malawi this time around. That's really good to know. So thank you very much for that. So just a quick recap over the usual formalities we do with the big when we start these sessions, so that we all have a good user experience or learning experience. So, like I said, at the bottom of your Zoom client, you have the chat icon, which I always say you should use if you want to raise any issues with the stream. For example, my audio is not clear, or you can't see what's on the screen. You can raise that issue in the chat section. For questions related to the presentation, you can use the Q&A section for that. And like I said, it's easier to manage the Q&A, the questions in that section of with that tool, that feature of Zoom. It's easier than using the chat section. So please, if you want to ask questions, please post them in the Q&A section. And then finally, if you want to ask questions by talking, you don't want to type, you can use the raise your hand button, and one of the co-hosts or myself will allow you to speak. And then we can hear your voice and what you want to tell us. All right. So this fine afternoon, I'll be your presenter here today. If you already know me, my name is Olatunde Awobiri, and I'm one of the trainers here with the Capacity Building Department here in Afrinic. So, ladies and gentlemen, you're all welcome to live session 3 on this 27th of September 2024. And this live session, as you've seen in the email communication that was sent to you on Wednesday, we're going to be covering IPv6 Neighbor Discovery Protocol. And then we will quickly look at the provisioning IPv6 configuration. And then also, we'll pause to take some questions. And then we will all invite you to take a survey, like we always do, to get your feedback about the session. And then finally, we will do a spin the wheel for the 2 lucky winners we select in this session today. Now, again, there's going to be quizzes along the way, and we ask you to please enter your first name and last name that you used to register on Zoom when it's time for that. Okay, and please do not close the browser tab that you've opened the Menti quiz on. All right, so it's easier for us to be able to track who's the top leader, who ended up at the top 5 at the end of the session. So please use your first name and last name, the one you used to register for the Zoom session when you want to take the quiz. And also do not close the tab. All right? All right. So let's dive into the field or the area of neighbor discovery protocol with IPv6. Now, before I start, when we started this first live session on Friday last week, I believe, most of the things we talked around were about the huge address space that IPv6 has. And we delved a little bit about some of the other features, like we looked at um, the fixed header size, for example, which I did mention was made the protocol linear more efficient for intermediate nodes to process. Now, today we're going to look at another feature, I mean, actually a key feature in IPv6, which is more than that huge address space that it has. So, but before that, we need to establish, understand, or categorize the different nodes you will find on a network, whether it's IPv4 or IPv6. So you have a node, a host, and a router. All right. So a node is a device, any device that implements IPv4, IPv6. A host is a node that accepts packets that are sent specifically to it. All right. And of course, a router is a node that can forward packets to other nodes. All right. Packets that send to it or to other nodes can go through it. So with a node, the key functions of IPv6 neighbor discovery are the address configuration, which we call stateless address auto configuration, SLAC. Link layer address resolution, which is the ARP equivalent in IPv6. Address change notification, the link layer address change notification also, in case you change your line cards or something. And then neighbor reachability detection. These are what nodes use ND, neighbor discovery, for. And then for hosts, it's for router discovery, and then the different parameters we'll see later on in this presentation. And then, of course, the routers also use ICMPv6 neighbor discovery to advertise their presence, advertise on link prefixes, and so on, which we will look at shortly. This is just a summary table. So basically, neighbor discovery exists also in IPv4 anyway, but the new thing we have here in IPv6 is neighbor reachability detection. So with address resolution protocol, you have the equivalent in IPv6. Internet router discovery protocol for IPv4, which is for IPv4 nodes to discover the router on their local network. We have that also in IPv6 now, and the redirect also we have in IPv6. But the new one here is neighbor unreachability detection. So neighbor discovery defines 5 ICMPv6 messages. All right. So again, remember a node, a router, and a host. So you have the first two here where you have a neighbor solicitation and neighbor advertisement. So like it's English also, soliciting the neighbor, and the neighbor answers with an advertisement. Now, either a PC or a host or a router can send either a neighbor solicitation or a neighbor advertisement. Now, the next two messages, ICMPv6 messages, are the router solicitation and the router advertisement. Same thing also, only a host. Yeah, a node also can do that. We'll see. We'll send a router solicitation, and only a router sends router advertisements. And then finally, the fifth message, the last one, only IPv6 routers will send a router redirect message to a host to optimize the next hop routing, which we'll look at shortly also. So these are the five messages, ICMPv6 messages for that neighbor discovery uses, or the neighbor discovery protocol uses. So let us look at the general neighbor discovery message format. So remember the first live session we had, we talked about the base header, which was 40 bytes in length. Now within that, you had the next header field, which is named protocol and the IPv4 equivalent. Now, in this case, the base header has the next header field, which has a code of 58, which means ICMPv6. So, and within the ICMPv6 header, you have plus message options comprise the neighbor discovery message itself. Now, within those options, you have a lot of them. All right, and later you see how one of them has most of it though. So you can have source link layer address, target link layer address, prefix information, redirect header, down to your DNS search list. All right, so you find these different options when we open the packet for ICMPv6. You can find these options in specific one of the no either one of the five NDP messages, which you will see shortly. Now, what NDP message is used for what option? All right, so as you can see in the table, let's see if I can get my laser pointer. So you can see in the table the RS for router solicitation, RA for router advertisement, and all the way to redirect at the end. And if you look at the router advertisement column, you see that it uses a lot of the options: source link layer, prefix information, redirect header, and so forth. All right, and you can see messages like the router solicitation and router advertisement use like the source link layer address. All right. So there are some addresses that you see a lot when you are looking at ICMPv6 messages on the link. And this is a table also that summarizes all of that. So the first one, which I believe we mentioned on the first live session on Friday, was the all nodes multicast address, FF02::1. The two in there being that it has a link local scope. And this is to reach all nodes on the local link. The second one, there's the all routers on the local link. So ::2 is for the routers, and the first two there, 02, is this link local scope. And then one of the addresses, which I hope we'll get we'll understand today exactly what it's used for and how it works, is the solicited node multicast address, which is the third row there. And it has the last 24 bits of a unicast address are added to it. I'm going to show you that briefly, shortly. And then on the fourth row, you have the link local address, which starts with FE80. You'll see how you use those on the local link, how ICMPv6 or Neighbor Discovery uses that on the local link. And then finally, we'll have the unspecified address, which is the : /128. And we will see how that also is used by different ICMPv6 Neighbor Discovery messages. So before we go further, we're going to have a short quiz. So like I said, please, when you want to join this quiz, use your first name and last name that you used to register for this session. And then you can go to menti.com, or you can scan the QR code on your screen. And like I said, please do not close that tab so that you can continue to follow me. All right, so we're 80 attendees in here, and I can see the player count is going up. Okay, waiting for us to hit 50, and then I will start the quiz. All right. So as you can see on your screen, the question is, which of the following is not an ICMPv6 neighbor discovery message? So you have 45 seconds. The first person to answer, the faster you answer, the more points you earn. Okay, that is correct. All right, so there was so 38 of you chose the correct answer. Yes, which of this is not? All right, so neighbor solicitation is one, router solicitation is another, redirect and router advertisements are other ones, but prefix advertisement is not a neighbor, the ICMPv6 neighbor discovery message, NDP message. Okay, so I hope that's clear. Now let's see the little board. This man, Matthew, eh? Okay, so, all right, you're the fastest again. So Matthew is the man to beat. All right, thank you. So let us quickly examine some of the first out of the 5 ICMPv6 NDP message. So the first one we're going to look at is the neighbor solicitation message. Now, this is sent by an IPv6 host, and you could use for 3 purposes, either of the 3. So, well, I hopefully will be able to show you some of them today. So one of them is to determine the neighbor's MAC address in the ARP equivalent process for IPv6, also for duplicate address detection. We will see later on that every time a unique local, link local, or global unicast address is configured on an IPv6 enabled node, it's going to do duplicate address detection. And we'll see how neighbor solicitation is used for that. And then, of course, to verify that the neighbor is reachable, which is the neighbor unreachability detection, which is new here. And then, so the source address for a number neighbor solicitation is the IP of the querying interface, if one exists, or remember the unspecified address I showed you on that table. The destination address would be the neighbor's address, okay, or the solicited node multicast address of target otherwise. I'm going to show you what that means shortly, okay? And we can just gloss over the notes for the type ICMP is 135. Now, the corresponding response to the neighbor solicitation is a neighbor advertisement, if you remember the graphic before the quiz. And this is also sent by an IPv6 host. The purpose is, of course, the response to the neighbor solicitation or to announce the MAC address change, i.e. unsolicited. So, like I said, in case you change your line cards. And then the source address is any address of the originating interface and the destination. So there are 2 of them, as you can see there. One of them is the IP address of the node who sent the neighbor solicitation. And the second one is, remember, the FF02:1 is the all IPv6 nodes on the local link, all right, for predict advertisements. And then, of course, the type is 136. Now, I mentioned the solicited node multicast address. I want to explain it a bit further now so that we'll have, a bit more clarity. So if you want to explode it out like that, that's the way it looks. It's a well-known prefix that is 104 bits in length, all right? If you remember Bashir's session on Wednesday, your IPv6 address. And on Friday also, which last week, which told you how you could do the 0 suppression and compression. But in this case, I'm going to suppress it because I don't want it to get lost in translation if I compress it. Now, so it's 104 bits in length. Now, what happens when I say solicited node multicast address? So, for example, you have the link local address at the top there. You take the last 24 bits of that link local address, okay? That's the lower order bits, the last 24 bits, and then you add that to the solicited node multicast address. Remember, 104 plus 24 will give you 128 bits. So this is the solicited node multicast address. Let me see if I have my pen here. This is the solicited node multicast address for this particular link local address. Now I'm going to go a little bit step further. Also in IPv6, remember we said there's no broadcast, or there are no broadcasts. So you also have a well-known MAC or layer 2 address prefix, if you're going to call it that. Remember, I believe Bashir showed us that on Friday last week. And this is, a MAC address is 48 bits in length. So usually in IPv6, when a solicited node multicast address is generated for a particular address, it could be link local. In this example, we have a link local. It could be a global unicast address, and it could be a unique local address. So now that solicited node multicast address that was generated has to be mapped to a MAC address. All right, so we have layer 2 multicast also in IPv6, because like I said, there's no broadcast. So what happens is that, in IP, your MAC address is 38 bits, sorry, 48 bits long, right? So what you do is that you take the 32 bits, because you have 16 bits right in that prefix, of the solicited node multicast address, and then you add that to the MAC address. Now, this one is the multicast, layer 2 multicast address. All right, so solicited node multicast address are generated for every unicast address. So the link local, unique local, and global unicast address configured on an interface, or whether it's automatically assigned or uh, or manually assigned. All right, and then that solicited no multicast address is mapped to layer 2 address also. And we will see how that works also, because like I said, there's no broadcast in IPv6. All right, so we look at the quick animation on how the neighbor solicitation, clear my drawings, sorry. So in this case, we have neighbor solicitation. Remember, it could be used for address resolution, it could be used for neighbor reliability detection, and it could be used for duplicate address detection. So in this case, we have a neighbor solicitation message sent by the PC to the home server, the home media server. And you can see in the Ethernet MAC address, this one is a multicast address. The destination address is a solicited node multicast address. Now, if you look at the upper layer here, which is the ICMP v6 inbox solicitation message, you have a target address in there. Let me change my color here to red, sorry. So you have this one, the target layer address, or the target address. That is the actual address of the home media server. Now, so what happens is that this address, this global unicast address, this is the corresponding solicited no multicast address. And then that is mapped to this layer 2 address. Now, the reason why I said, because the thing is, if Ethernet NICs will filter a multicast address without requesting or sending the event up to an upper layer protocol or the operating system. All right, the NICs themselves can filter there and then. In IPv4, since it's a broadcast for ARP, it has to go through the upper layer process. Let me clear my screen. So let us quickly take, actually, there are 2 quizzes. Let's see. Whoa, we're all here already. Good, good, good. I'm happy to see that. All right, 60 players. I think we're good to go. 86 of us here. All right, so that's the global unicast address we have there. So which of the following is the solicited node multicast address for that global unicast address above? We took your feedback, so you have enough time to look at the address and the options, and you can select. I am very happy with this result. Okay, so this is not correct. It doesn't even have the last 24 bits. So if you don't even see 9 for A or 5, at the end here, it's wrong. Even though it starts with the correct prefix, FF02, this one starts with the wrong one, FE08. And 08 is not even, I know Bashir will catch you guys with some of this with the link local. It is not, it's 0, it's 0, but this is wrong. Definitely not this, and not that. This is all routers. This is all IPv6 enabled nodes on a local link. So this is the solicited node multicast address for that global unicast address. Okay. Let me then raise his hand. Yes. Is it a question
Hello, good
pertaining to
morning.
morning?
Yes, see, I got stuck with this menti.com. I've not been voted since. Please, anything you can do, sir. Please, sir.
You've not been what?
I've not been voted on menti.com.
Okay.
Yeah, I don't know what happened. Please, thank you, sir.
All right. So let us look at the board. Let's see if things have changed or things have moved. Ooh. So because I'm kind of got to you, Matthew boy. All right. Let us look at the second quiz. So again, like I said, use your real name, first name and last name. When you started today, you don't close the tab. Okay, and scan the QR code on the screen and type in 136118882. Number is going up. Okay, it's fluctuating. All right, so let's start the quiz. So the question is, what type of ICMPv6 neighbor discovery protocol message uses a associated node multicast address? You should have said for its destination. But we just covered that. So 70 people voted. All right. So that's the only one we've actually covered so far. So we examined in detail. So yes, it's actually neighbor solicitation, and I showed the beginning. What I showed just now was for a neighbor for address resolution, ARP equivalent in IPv6, and it was sent to the solicited no multicast address for the target address. Okay, so it's not the router advertisement, neighbor advertisement, or the router solicitation. So if you have any technical details pertaining to this stream session, including the quiz, please post it in the in the chat section. Okay, please. Let's look at the leaderboard. Why do we have someone struck out there? Okay, now they're back. All right, Matthew's taking back his top spot. I don't know how he's doing it, but okay, there we are. So thank you for that. So the second message we're going to look at is the neighbor advertisement, the corresponding response sometimes to the neighbor solicitation. And as you can see in the graphic on your screen, the home media server, because it was address resolution, remember the neighbor solicitation was sent to a multicast layer 2 address. It solicited no multicast address as a destination, which was the solicited no multicast address for the home media server. All right. And that is generated from the global unicast address that was assigned to the server. This 2001 DB8 cave, cafe, colon one, colon one, like a feed. So the neighbor solicitation, the neighbor advertisement, sorry, you can see the destination and source marks are those of the other machines. The same thing with the source and destination address. But the interesting thing here, or what we're looking for here, is the target link layer has been, this is a MAC address that was requested for in the target link layer of um, the neighbors, neighbor discovery message, ICMPv6 neighbor discovery message. All right. So this is a neighbor advertisement. It's a response. It can be a response to a neighbor solicitation, or if it's unsolicited, like for neighbor unreachability detection. It's just like in that sense, it's like a keep alive, like for routing protocols. So duplicate address detection, one of the uses of neighbor solicitation. In this scenario, you have NS2 and NS1. You have NS1 is configured with that address, 201 db8 cool, colon 10. And you configure the same address on N2. So what N2 does is to send a neighbor solicitation ICMPv6 neighbor discovery message. All right, as you can see there, the source is unspecified because it doesn't have an address yet. The destination is the solicited node multicast address for the target address. Okay, remember the last 24 bits here are added to the last 24 bits there. This is 104 plus that 24 gives you 128. Okay. So now N1 will respond with a corresponding neighbor advertisement. Okay. And as you can see here, it responds that the source is its IPv6 address. The destination, you can see this is another, remember the addresses we use in ICMPv6. This is the all nodes multicast address, all nodes on the local link, scope of 02, and the target field has the address that N2 tried to configure. And N2 knows this address is used by N1. All right. And then finally, we've quickly look at neighbor reachability detection. Like I said, it's more like a keep alive, just to know if the neighbor that you are communicating with is still there on the local link. All right. So it's done with the neighbor solicitation also, but you can see here it's done with the link local addresses of both. And the neighbor advertisement has the solicited flag switched on in this case. Okay. So you have different states of a neighbor, IPv6 neighbor, and the neighbor cache of an IPv6 node. So you have the incomplete state. So address resolution is still in progress in this particular state. So you're still trying to do ARP. All right, and then you have the reachable state. Basically, packets have been received, providing confirmation that that host is still. So in this case, host B you've received packets from host B, meaning the host is there. Okay, so it's not reachable. It's not incomplete. And then you have a stale. Okay, so within a time period, you have not received, message communication from host B. All right. I should be able to show you this today, hopefully, if the stars align. And then there's a delay. There's the delay state, which is basically this one is within a certain time period, or known as the reachable time, has elapsed since a packet has been received from that address. Okay. And then there's delay. Excuse me. Delay. So in this case, maybe you see when I show you some demo today. In case sometimes when you let's say host B goes offline and comes back online and there's a readdress resolution or re-resolution, it's a long word, tongue twister. In this case, there's a delay already. And then finally, the probe when you're actively trying to find if host B is still there. So do not worry yourself too much about this one. Now, so I'm going to try to show you some of these messages on link. Let's see how that works. So in this very simple topology, this is the router, the end. So this node, PCA, the switch, and PCB, they are all on the same link, even with the router. Okay, even though you can see there's a switch there. All right, they're all on the same link. So the first one we want to look at is maybe the neighbor solicitation. How is that triggered? So I have a simple GNS3 network here, and I put a small packet capture on this part of the network, which is between the host A and the switch. All right. Let's see, and I have my packet capture here on the screen, which is not showing much. All right, so we see some spanning tree stuff from the switch there. All right. So if I go to PCA, so in this case, PCA, one second, let me see the screen sync. Okay, fine, sync now. All right. So PCA, I switched off it's not the network interface. All right. So if you look at it, I have it's manual, and I've configured this IPv6 prefix on it. All right, with a /64. So it's 2001 db8 ball :1 :2. All right. And if we look at the command line, let's look at if we have any IPv6, IPv6, sorry. So the only thing we have here is remember, unspecified address. Okay. So what happens is in the manual state now, what happens if I switch on that interface? Let's check out our capture. Let's see if we have anything. So we do have something happen here just now. So let me just filter all of that and drop in ICMP. All right. So remember, I configured this address 2001 db8 ball :1 :2 on that interface manually, and then I switched it on. So what happened was that node, which is I believe host A, PCA, sent a neighbor solicitation to know if that address is unique on the network. All right, so if we expand that, this is it. You can see, look at the Ethernet link. You have the destination is 333F. You can see that that is a layer 2 multicast address. All right. On the Internet Protocol level, the source address, Emmanuel says you can't see. I can see on my monitor here. I hope you can all see. All right, so I hope we can see what I'm showing. Okay, good. So when I switched on the interface for PCA, which I manually configured, the prefix 2001 db8 :ball :1 :2, PCA sent out a neighbor solicitation for that address. So I said, we're looking at it one by one. So I said, if you look at the link layer address, that is a layer 2 multicast address. If you look at the layer 3 address, the destination address, that is a solicited node multicast address. And it's the solicited node multicast address for that prefix I configured manually on PCA. So if you go into actually the ICMPv6 message itself, you see in the target field, let me open that. I can see there's a lag. All right, good. So I open the internet control, the ICMP header itself. You can see the target address there. So this is this neighbor solicitation packet. And from what I can see here, this is used for duplicate address detection. What PCA tried to do when I switched off that interface was to check if there was anybody or any node on that same link that had the same, or using that same address. So what it did was that it sent a solicited a solicited neighbor solicitation message to the solicited node multicast address for that address I configured on it. All right. And you can see the target field there. So because if I go to, let's go to PCA. Claim my drawings. So if you do, this is PCB, sorry. Okay, so let me wait for it to sync. All right, so this is PCA. Before I switched off the interface, I did not have, I just had the unspecified address, but now I have the address I configured manually and the link local address. This is generated automatically, link local addresses, all right? You don't have control over that. You can put it manually, but usually when you enable an IPv6 node, a capable node, it generates a link local address automatically. So you can see here, PCA sent a neighbor solicitation message on the link to check if this address, the 2001 ball, is unique on that link. All right. And because if you look at, let's look at the, so PCA, for example, these are all the multicast addresses that it's listening on. So as you can see, let me do that slowly. One second, this link local address here, this is the solicitor node multicast address for it. This global unicast or documentation prefix. This, no, sorry. Do that. The one below it, sorry, I can clear my screen quickly. The one below it, yeah. So this one. So you can, see it ends with 2. So you can tell it's the solicited node multicast address for that. So that means if there was another node on the network that had the same global prefix, it will be listening on that multicast address. All right. So for each address you configure, as you can see here, both the link local and the global unicast, you have a corresponding solicited node multicast address generated for them. All right. So that's the neighbor solicitation message. All right. So how do we now get a neighbor advertisement? Let me bring up the router first. Let's see if I can. Let's see if we play my screen. Make that bigger. All right. So on the topology, Ethernet ETH0 is the one that has a interface. Sorry, ETH0 is one that's connected to the switch. So I'm going to quickly configure an IPv6 address, the same one, 2001 DB8, if I remember. I think it's ball :1::1. This is the gateway /64. And I press enter. Interface is up, but we can't be sure. All right, so let us look at what we have also here. Okay. All right. Okay, so what happened here, the router, when I activated the interface, it also did a neighbor solicitation for its link local address that was just generated. Okay, so remember I said you have node host and router. Now, because in this case now, this router is just a node. That's why it's also sending enable solicitation message. So now I'll quickly show you how we get enable advertisement, and then we move on. So how do we trigger enable advertisement? In this case, I know for sure that PCB has a specific, let's try to configure that. So I know PCB, let me just copy this. This is the address for PCB. Let me switch off that interface and I switch it on again. And I see that I have that address configured. But if I go to the Wireshark capture, beauty of oh yes, my bad, sorry. PCB is interface is off. That's why, sorry. There we go. Okay. Sorry about that. All right, good. So back to the Wireshark capture. I forgot to switch on PCB's interface. They were off before the live session started. So what we see here now, when I configured on PCA, the address for PCB, there was enable solicitation, all right, for that address. Okay. And same thing we have, if we go through all the layers, you have a layer 2 multicast address, you have a solicited no multicast address for that particular global unicast address I just configured. And then in the target field of that enable solicitation is the actual address. Okay. And then if we look at the corresponding enable advertisement, that was the response to that. This is the name of advertisement. This came from PCB. See, I look at the source and destination addresses. The PCB's unicast address, and then the destination is all links. I mean, all IPv6 nodes on the local link. All right, and with the target field in there. Okay. So if we go to PCA now, and we go on the command line, clear that. And we try to look at our IPv6 addresses. We have this because we have the address there. Now, actually, that is meant to fail because let me close that. Let me redo it. Let me redo it because I did not enable PCB before I started. Sorry. All right. So let's do that again. Let me just reconfigure it. Sorry. All right. right? And then we see the beauty of live demonstrations. Sorry, I bit the gun there. So, all right, good. All right, so now here we go. So, like I said, so when the neighbor solicitation is sent, let me move on from this because when the neighbor solicitation is sent, you get a corresponding neighbor advertisement. Now, in this case, when I configured the global unicast address, the same one for PCB on PCA, PCB is responded with the neighbor advertisement saying, I have that address. And that's meant to be the duplicate address detection. So neighbor solicitation, like I said, is used for duplicate address detection and for link layer address resolution, ARP, and then neighbor reachability detection. All right, so if I do on PCB, let's say I want to ping all nodes. Let me look at my interface identifier. Let's see, sorry. Okay, it's EN3. All right, so now I'm pinging all the nodes on the globe on the local link from PCB. In this case, I also expect to see a lot of things going on here. All right, so there'll also be neighbor advertisements sent. Let me stop that. Oops. Okay, so there was a little mistake I made here. I wanted to show you how link layer address resolution happens, but it didn't happen in this particular try. So like I said, that's the beauty of live demonstrations. So let us quickly move on then. But what, in a nutshell, what I was trying to show you is that when you configure the same IPv6 address on a different node on the same link, what you will get a neighbor solicitation for that address, and then the node actually has that address is going to send you a neighbor advertisement back, and your the duplicate address detection is going to fail. Okay. All right. So let us take a quick quiz. Let's go back to the slide. So let's see, 90 of us. So we have 55 players. Please, I said, do not close the the tab. So you go to menti.com 13611882. That's the code you type in. All right, number is going up. All right, let me start the squeeze. The answer to this was in one of the animations I showed. I wanted to show you on the link itself. But yes, I did show you actually with the neighbor solicitation message. So you have the answer to that there also. So the question is the source IPv6 address field in an ICMPv6 neighbor solicitation message during duplicate address detection contains what? A solicited no multicast address, a link local address, an unspecified address, a global unicast address, and an all nodes multicast address. Okay, so I will not blame people who chose it wrong, because I could not show you on the live demonstration. Well, I did show you the neighbor solicitation, but for a neighbor solicitation message, the destination address is usually a solicited node multicast address, especially for duplicate address detection. But for maybe even app in the beginning, when it's unreachability detection, then it can be a link local address. So the first one is not correct. Same thing with the link local, because this is duplicate address detection we're talking about. So usually the source, not the destination, the source is unspecified because you do not have an address yet, and you want to know, know if anybody's using that address that was just manually configured or automatically assigned to you, and then so you don't put an address there. It's unspecified. So it's not a global unicast and it's not all nodes. All right. All right. Let's see the leaderboard. Ian is now on top and is just a bit ahead. All right. So, okay. So let's move on. Let's look at the third message, which is the router solicitation. And this, if you remember when I started this presentation, is sent by a host. All right. And the purpose is to request for routers. We want to know where's the router on the segment, basically. And in the town you see for network parameters, because I don't know how I'm going to configure myself. I mean, what addressing method I'm going to use. And the source is usually the link layer address of the querying interface, if one exists, or this in case also router solicitation can be unspecified, all right, if there's no IP address yet. And hopefully, if the stars align, I'll be able to show you that. So the destination address, remember, one of the multicast addresses you use in ICMP-v6 neighbor discovery is the FF02::2, which is all routers on the local link. And the ICMP type is 133. And then, in my opinion, the biggest of them all is the router advertisement, which is sent only by a router, all right? And its purpose is to advertise its presence on the link. And then there are other options we'll see later on. And the source address is the interface, the link local address, the link local address on the interface. And that's why you see I mentioned on Friday that it's only the router that gives default gateway address to a node or a host on an IPv6 segment, all right, not a GCP server. And it's usually a link local address. You can configure it manually with some other address, but if you get it from the router advertisement, it's going to be the link local address. And of course, periodic router advertisements go to all nodes on the local link, And the one that is solicited basically is a response to a router's solicitation from a node that just booted up or something. All right. So let's quickly look at how the router solicitation message looks like. So PCB just boot up and it's trying to find its router on the segment. So it sends a router solicitation message. Okay. Usually it's when a node or a host is set to automatic that you see a router solicitation message sent out. So the destination MAC, again, you can see there, it's the multicast. All right. And the destination IP address is all routers on the local link. Once a device is enabled to be an IPv6 router, one of the things it would do is to join that multicast group and start listening for router solicitation messages on that group, FF02::2. All right. And then the source link layer field in the ICMP header is there. So the corresponding router advertisement from the home router will have the destination MAC of PC and then the source MAC of the IP router itself, which I said is usually going to be the gateway address. And then the source address is the source IPv6 address, is the gateway address, which is for the router, the link local address of the router. The destination address here, you can see there are two of them. And with my laser pointer away from there, it can either be link local, all right, if it's a response to host the home PC, for example, here now, because it's sent a router solicitation. Or if you configure the router to send out router advertisements periodically, it's going to be sending it to the all nodes on the local link multicast address. And then within the ICMPv6 router advertisement option there, that you have a lot of options. One of them is the prefix. You have different flags, which we will look at shortly. MTU size, the default router time, router lifetime, so many of them. All right. All right. Let's see if we can. Let's see if we can invoke a router solicitation message. Let's try it one more time. Maybe the third time will be the charm. Okay, so what I'm going to do on PCB, I'm going to switch off not the PC, the network interface card, sorry. I'm going to switch that to automatic, and then I'm going to switch it on and off. Automatic means I want it to automatically get a IPv6 address assignment. So let's look at if anything happened here. So thank the heavens, we got router solicitation from this PCB. Oops, let me drag that up. So this is a router solicitation message because I just configured PCB to, did away with the manual configuration, and I said it should take automatic assignment, and it sent a router solicitation. All right, so in this case, this is the link local address of PCB, which ends with 2153, and it sent it to all multicast routers on the local link. I'm sorry, all IPv6 routers on the local link. All right, and you can still see that it's still sending the router solicitation there. All right, but there is no corresponding router advertisement yet, just yet. So let us see how we can trigger that. 1 second, I'm closing stuff from my other screen. Yeah, all right. So I popped up a lot of my Wireshark screens on my other monitor, sorry. So let's go to the router, yes, the router. It's still online? Okay, so what I'm going to do, this prefix I configured, okay, let's just configure on that prefix. Mind you, I can configure as many IPv6 prefixes addresses, sorry, on an interface. It's going to accept them. It's not going to override. So let's use 2001 DB8. Let's see, feed. colon 1, colon 1. All right, /64. And then we enter that. Now I want it to send this as a router advertisement on the to all to all nodes and local link, or a response to any node that sends a router solicitation. So in this here, I have the option. Okay. So IPv6 ND, that's neighbor discovery. All right. We'll put the prefix. And then we put DB8 feed 1. Sorry, nope. The prefix itself, not the 64. Yeah. Seems there are a lot of gremlins. Okay, so what? Okay, let us see what happened first. All right, so nothing has happened yet. Why? Because this router is not a router yet. It's not an IPv6 capable router yet. It's just a node, IPv6 node right now. So I say no IPv6 enable discovery. I think it's suppress router advertisement, and I hit enter on that. Now it's an IPv6 router. Now you see a lot of router advertisements coming up here now. So let us catch one of them and expand that, and then we see what's going on. So in this case, if we look at the, let me slow down, so it's syncing up. All right. The source is the link local address of the router, and the destination is all nodes on the local link. It was a router advertisement all out, okay? So, and then if you look at the different flags here, different options here, there's the router preference. We're not going to look at that yet. We'll look at them shortly later. There's very lifetime. Now the prefix I configured, this is what it's included there also. All right, this is not the IP address, it's the prefix, the network prefix, the /64. All right, the prefix information option under there. All right. So let's go back to the presentation. So what I basically did is that I configured this guy to send router advertisements. That's all. All right. So finally, I hope we understand what the router solicitation and the router advertisement did. So finally, the fifth message is the redirect message. My screen. Yeah, so it is sent only by an IPv6 router. The purpose is to inform the node of a better next hop for the destination, or I say used for optimized next hop routing. And the source address is the link local address of the router. The destination is the address of the requesting node, and the ICMP type is 137. So here I'm just going to show you an animation. We're not going to get lost in the configuration for that. So IPv6 router redirect. So in this situation here, we have the host connected to the switch at the bottom, and we have these three routers: R3, R2, R1. Now an IPv6 host, you have what you call a default router list. So because you can have more than one gateway actually in IPv6, but if we let me see if we can show you that in the. So you have a router preference, because I've gone back to the router advertisement here. So based on what you configured, there's a router preference that's high, medium, and low. Okay. So based on that, for a particular destination, the router will use that router for that. The host will use the router to reach that destination. So let's go back. So here in this case, you have a default router list in this situation for the black host at the bottom of the screen. And this is just to make it simple. It sends out a router solicitation. This is on the link, and it goes to those two routers. Now, this is not because the router 1 is slow or router 3 is fast. I just wanted to make it simple. So they both generate router advertisements, but in this case, I just showed router 3 to send it first, but that's not the case. Like I said, it's tied to the default router router preference for the default router. All right. So, but in this case, the node or the host thinks router R3, the red one, the one labeled in red, is the better hop to reach the external network, the blue network. So when it wants to configure, so as you can see in the default router list, I put it on top, all right? But there's meant to be a value. So when it sends a message, to R3, as you can see there, R3, if you look at the topology, has to go to R2 and R1, then get out. That is a longer path. But through here, it's just one link, it's a shorter path. Okay. If it sends that message out the same interface to forward it out, it knows the host that sent it does not know of a better next hop. So it's going to generate the, let me clear my drawings. It's going to generate the redirect message, IPv6 redirect message. And you can see here the source is the link local address of R3, the router itself. The destination is the host that is not getting off the next hop optimally, routing optimally to the next hop. And then the target address is the better next hop. That's why it's redirecting the node to, or the host to the better next hop. And that message is used to update the default router list accordingly. Okay. So subsequent messages will go out to, for that particular, the optimal path to that network will go through R1 now this time around because of the router redirect that R3 sent back to it, because that was not the optimal path to it. So we'll quickly look at the states of every IPv6 address. And so when when a link local address, a unique local or global unique access configured, they all start in the tentative state. Okay, they're not going to, like, you can't transmit or receive anything on that. All right, and then duplicate address detection that I couldn't show you is going to take place when you configure it on it. It's going to take place, and then basically, what's duplicate address detection? Like I said, the node you just configured this on is going to send a neighbor solicitation to the solicited node multicast address for that particular address you just configured on it, or assigned manually or automatically, doesn't matter. And then if that passes or it doesn't fail, it's valid. That means that address is valid. I was trying to show you the failed one. And then if it fails, that means there's a duplicate. That means on the same link, there's someone that has the same address. That means failure means somebody responded with a neighbor advertisement, and in the target field, it says, this is my address. Okay. And then if it's valid, you're going to check, because in the router advertisement, I'm not sure, anyway, we'll see later. So in the router advertisement, you see the prefix, there's a preferred lifetime and a valid lifetime, all right? So in this case, if addresses, the duplicate address detection process passes or is successful, sorry, you're going to check, because that means the address is valid, and then you're going to check if the preferred time is greater than 0. All right. If it is greater than 0, that means that address is preferred, and you can transmit or receive. You can start new communications or connections with it and receive communication on it also. Now, if the preferred lifetime is not greater than 0, you're going to check the valid lifetime. The valid lifetime is either the same with the preferred lifetime or more. I've seen recommendations of 1 for 4. So you have 4 times the valid lifetime. Preferred lifetime is 20 seconds. So let's say you have 80 seconds for the valid lifetime. You have 20 seconds for the preferred lifetime. But in this case, if the preferred lifetime is not it's not greater than 0, you check if the valid lifetime is greater than 0. If it is greater than 0, yes, the address is not invalid yet. It's just deprecated. It's on its way out. But in this case, you can only continue with existing communications that you're having before the address went into before they were deprecated, all right? But you can't create new ones like you have with the preferred on top. And of course, if the valid lifetime is less than 0, that means the address is invalid, all right? It's out. Okay. All right, so let us quickly look at just one concept with the NDP security considerations, and that is the concept of the router advertisement. Like I said, that's the kind of the one that has the biggest number of options and that you can tinker with. And so in this case, it's possible for an attacker to on the same subnet. So that's why we say security first. You lock everything, everything's on that key, but on the same link. They have to be on the same link to do this attack. They can masquerade or pretend to be a router on that link also and send fake router advertisements. Okay. So in this scenario, you can see here the whatever the hacker or whatever on the local link which is sending the prefix. Send that prefix that it's to reach it, you have to go through them. They are the gateway for that. All right, because PCA is going to use that red, this one, as the gateway address. All right, to get off link for that prefix. And it's saying, and one of the options in the router advertisement message, if I can see that, is the router lifetime. You see the default is, let me wait for that to sync. So one of the fields in the router advertisement message is the router lifetime, okay, which is refreshed every time you get another router advertisement. All right, so it is 1800 as you can see here, and you can see in the graphic, I believe it's 1800 also. All right. Clear the screen. So, and of course, the default router list for the PCA gets, written with that, with the bad router advertisement. Okay, and even worse because the attacker can even send the same prefix, the same router advertisement, but this time around, it can say the lifetime. You can see the lifetime of I showed you on the router advertisement now. Its default is 1800, but here you can change it to 0. It's something you can change to 0. The attacker can do that, and that means that router is not accepting any communications to for that prefix. Basically, it's a denial of service. All right. So there are ways. One of the ways around this is to use the router advertisement guard, which is usually implemented on switches. It's layer 2. Okay. So on your link, of course, first of all, everything has to be lock and key. But you have to make sure that on the switch port that the router is connected to, you have the router advertisement guide. That means all other open ports or unused ports are not, you cannot connect a router to them, and it's going to forward the traffic. Now, but even for the router to for the switch to forward that router advertisement, there are different parameters it checks. All right. So one of them is the source MAC address. So unless the bad guy has spoofed that, I don't know. The source IPv6 address, source IPv6 address prefix, the router preference priority. It's very granular. Okay, so you can use that to filter. Sorry, you can use that to filter any of the. Oops, I jumped the gun to the quiz. Sorry, you can use that to filter. You can create a filter on the switch that accepts only router advertisements that match all those parameters, because you know what you configured on your router, and that's the thing that will go through that switch only through that port. All right. So I'm not sure if let's see if my switch is still alive here. Guess it's usually okay. So I'm not going to configure. I just show you the options you have on this one. Let's see. So it's a global configuration. So you say IPv6 on this switch, for example, if I wanted to, I would just type, let me make that large, sorry. If I can see. Okay. So my array guard policy, basically just configure it on it. And let's say this one is I don't know, live session 1. I mean, live session 3, sorry, LS3, and enter. So now I'm in the router advertisement guard configuration mode. And I'm not going to configure it, but if you look at this one, for this particular one I have here, the options I have, I can set the different command. The default device role is either router that's connected to that port. All right, the exit, the hop limit. You have also there's a default hop limit for router advertisements. I think it's 64, if I remember. Does it have the manage config flag on? Okay, no batch prefix list or access list, and so on. Or is the other config flag on, or is the router preference? What's the router preference? Okay, so these are the different options you can configure on the switch that supports router advertisement guard, so that you don't have rogue routers on your local link that's denying you services or whatever on your link. All right. Okay, so let us go back to the presentation. So let us do a quick quiz again. Start the quiz. Let's see how many of us are still with me here. 48 players. All right, going up. So we are 86 here. So I think 64 I have on my screen. 65 is a healthy number. So let us start then. Just a quick. So what is the primary purpose of router advertisement guard in the IPv6 networks? That's an easy one, I believe. Yes. So it's to prevent rogue router advertisements from unauthorized devices. That was the quick one. All right. So it's definitely not to encrypt router advertisement. You don't encrypt that. And to compress router advertisement headers, you can increase the frequency of router advertisements, but it's not with the array guard feature. All right, for this one. Okay, let's see this little board. Let's see, it would be Ian. Matthew's just right behind you. Ian is still on the top. Okay, awesome. Oh, Malawi. So yes, so array guard validates all of this, which I showed you on the command line just now for the switch we have in that simple topology. All right. So let's just quickly move to, excuse me, provision IPv6 configuration. Here we see more of the route advertisement. So the base address provisioning requirements for a host to get access to the network, you need definitely an IPv address, IPv6 address. You need a default gateway to get off your local link, and you need the internet phone book, the DNS servers to resolve domain names to IP addresses. Okay. Now for the CPEs, the customer premises equipment, you see how the same thing. You have, the first three are the same. You have an IP address for the WAN connection to the provider. You have an IPv6 default routers, and then you also have DNS servers also. And then finally, you have the delegated prefix. which is the new one here, which we don't have in V4. I don't think we have the luxury to have that in V4. So there are two key provisioning mechanisms, okay, in IPv6. I did a bit of it just now. So you have router advertisement-based stateless address auto configuration, all right? And then you have DHCP v6. So both of them will give you an IPv6 address. You can get it from the DHCP v6 server or route advertisement. You can actually do that. Hopefully, we'll be able to show you that. And then you can also get DNS config from both the route advertisement now, wasn't the case before, and you can get that also from DHCP v6. And of course, the big one there is you get your default gateway only from Slack-based route advertisement, stateless address auto configuration. And with DHCP v6, you get a delegated prefix. Okay. And other configuration options, of course. So we'll see that with stateless DHCP v6 shortly. So Microsoft Windows does not support DNS via route advertisement. So if you remember the very first, earlier beginning of this presentation, I showed you some of the options. And one of them was for the DNS search list or recursive DNS servers. You can, host can get that information to configure that information from a route advertisement. But I could check again. I know Windows did not support it, but I saw some thread that Windows 10 supported and now Windows 11 doesn't support it. I don't know. I've not tested with Windows 11. So it seems it's all over the place. Support for DNS via route advertisements with Microsoft Windows. So comparing the capabilities of these methods. So again, this is like a tabular format, as you can see. So for Slack, you get addresses, you get default gateway, DNS info, no. Legendary prefix, no. For stateful DHCP v6, you get address, no default gateway, DNS info, yes, and delegated prefix. For stateless DHCP, you only get DNS info because it's the same for everyone, basically. So stateless, you don't keep track of that. You send them the same thing, unlike if it's an address where you have to keep track of state of that. And then the recursive DNS server option, ARIA option, also. So for addresses, no, you don't get that. Default gateway, no. DNS info, you get that, yes, for that, and no delegated prefix. Okay. So let us take another quiz. Still a lot of us here. That's good. 88 to 67. I think that's the healthy number to start also. So let's start. So which of the following statements about Slack, that is stateless address auto configuration, is false? Okay, sorry, I was looking at the chat section. I see you saying about the screen. I hope it's clear now because I have another screen connected. I can see what you can see. I see a bit of lag, but I see what you can see. So, so which of the following statements about Slack is false? So, none of you got it correct. It requires a DHCP v6 server to function. No. All right. It uses IPv6 message for communication. So the question is false, not true. All right. So it is true that it uses IPv6 for communication. All right. And it is true that it can work in conjunction with JCPv6 for additional config options. We'll see that shortly. All right. But it is false that it requires a JCPv6 server to function. It can function without that. So let us look at the leaderboard. Oops. I jumped the gun. All right, let's show the leaderboard first. Okay. Oh dear. Matthew has dethroned Ian. All right. Fair enough. All right, let's move on. So there are flags in the route advertisement. All right. So within the RA message itself, the route advertisement message itself, you have an M flag, which is basically the managed configuration flag. Okay. You have an O flag, which means other configuration flag. And then within the prefix information option, which was one of the things I showed you just now on Wireshark, you have other flags. And within that flag, you have the L flag, onlink flag, and the A flag used for automatic means automatic. So used for stateless address auto configuration. Okay. So we're looking at this summary of this table now is showing you how the flags influence each other. So you have the M and A flag. So now what does the M flag mean? Let me roll back. What does the M flag mean? Let me roll back a bit. So the managed config flag in the router advertisement, if that is received by a host who sent a router solicitation, it means it's telling the host, the router is telling the host that you need to get your address configuration and DNS and all that good stuff from a JCPv6 server. All right, that's what the managed config flag stands for. Now, for the other config flag, if it's on within the router advertisement message received by a node or host, it means you should get other configuration, usually DNS information, from a stateless DHCP server. Like I said, the stateless DHCP server does not keep state because it sends the same information to all the nodes on the network, so it doesn't have to track. So this is what the O flag says. So it's saying get your configuration parameters, usually DNS, from a stateless DHCP server. And like I said, the L flag on link flag tells the host that this prefix is on the link. All right, you don't have to come to me to reach that host. Now, if it's off, it means it's off link. That means you need to go to the router. In IPv4, it's done with ANDing, yeah? to know if you're on the same subnet. All right, but here it's used by a flag is used. Okay, so if if it's on link, it means you have that prefix. That means to reach other hosts, in that network, they are on link. If it's on, if it's off, that means you need to go to a gateway, the router itself. All right, and then of course I mentioned A is for automatic configuration. That is stateless address auto configuration. So that's how I'm now looking at how they influence each other. So if you have the managed config flag, which says use a stateful DHCPv6 server, and the A flag, which says you should use stateless address auto configuration Slack. If both of them are off, it says there on the right, no addresses will be auto configured because they are both off. The two options, DHCP and Slack by route advertisement. Now, if you have the managed config flag is off and the A flag is on, which is automatic, addresses generated from prefixes in the route advertisement. Okay. when I configured router advertisement on that router just now, I said no auto config because I did not want, yes, I wanted to send the router advertisement, but I did not want the host to auto config using that prefix because we've not gotten that yet in the presentation. All right. Now, if you have both managed config flag on in the message header and in the prefix information option, you have a flag on, you're going to have, well, you see, you can have multiple addresses on an interface anyway. So you can generate prefixes from the one in the router advertisement via the A option, and you can also get the M option. I mean, manage config, meaning you get another prefix from the IPv6 server. Now, if you have the M flag on and the O flag off, meaning manage config, go to the stateful IPv6 server, and the O flag is off, you get all your addressing from the server itself. All right. Now, it's all, like I said, I just said that I did some quick research when I said something about Windows. I saw 10 supported router advertisement DNS options, but 11 after some update, I saw some complaint on Reddit or somewhere there. So you need to test how these things work depending on the different operating systems you're using in your environment. You just because they behave differently. Okay. So let me see. Let's see. Let's see if we can, before we close, let's see if we can get automatic address assignment. Let's see if our router is still online. All right, the router is still there. And I think PCA is the one I set to automatic, if I'm correct. Yes, it's automatic. Okay, and let's see what IP addresses it has. IP. All right, so it still just has a link local address. This one, which is automatically generated because it's in auto mode. If I am correct, let's check that again. Yep. All right, so let's go to the router. And this time around, I want to advertise the prefix. So let's say IPv6 via router advertisement and the prefix. Let's use another prefix this time around. Since I said no auto config, as you can see in this, because I said I don't want the nodes to use that for auto configuration. So 2001, let's say DB8. Let's use food this time around because I'm hungry. And then let's use 1. This is the prefix, and then /64. And let's see if we have other options. I know the options, but I want you to see it. Let's see. All right, let me exit from that. Let's configure terminal again. Let's see. That's the beauty of open source and live demonstrations. So ETH0 is the interface connected to these guys. So it's IPv6 ND. Prefix. So this time around, I'll put the food there again. DB8. That's food. /64. So in this case, I want to put a valid the valid lifetime. Let's say I'll put it at 80,000 seconds. And let's put the preferred lifetime as 0, 0, something like that. And I press enter. I've already configured it to advertise run advertisements. So let's see if anything happened on the Wireshark end. Okay, so there was one router assignment sent out. So let's look at it one by one. So the type 134, if you remember, I didn't alter the default router preference. You can alter that. The prefix I put in it is this prefix. No, sorry. That's the food one, sorry. Oh my. Okay. For some reason, I'm not having the context sensitive help. All right, maybe another day, because I wanted to show you, because under the interface configuration mode, as you can see, this is the FIR router, the open source routing software. It's almost like Cisco iOS. So if you, ideally, I should have the options, if I know, like in Cisco iOS context sensitive help. I don't want to reboot it so that I don't waste your time to look at it, so that you can see the different options on that. So one of them, all the options, so all the preferred router lifetime, the preferred router, sorry, the default router preference, the flags, MO, all of them, I can adjust all of them. I don't know whether they don't work right now. We're working just before the session started. I don't know. So this is the case with this one. So let's quickly look at the presentation then. So because I didn't want to just show you this. So yes, this is the configuration. I wanted to show you, I wanted to demonstrate it for you. So under the interface, in this case, we're enabling. So before the router advertisement is sent out, you want to enable the manage config flag and the other config flag. All right. So what does that mean? Manage config flag means get all your JCP v6 server. I'm sorry, get your address configuration from a full JCP v6 server, and then the O flag says you should get other configuration, usually DNS, generic information from a stateless JCP v6 server. All right. So how does stateful DHCP work? In the famous Lady Dora for v4. 1 second. Let me quickly do this while we do that. Okay. Back to the presentation. So, but in v6, so in v4 you do the discover Dora, right? Offer, request and acknowledge, yeah? So here, I don't know if it's called stars. So you solicit. So, but how does it start? So you see here, the node itself starts with the neighbor solicitation. I mean, the router solicitation. A host sends that. Remember, that was the third ICMPv6 message we looked at today. And then the router responds with a corresponding route advertisement with the M flag equals to 1. Okay? Meaning, get your addressing information from a stateful DHCP v6 server. All right? So in this case, we send a solicit, right? Not a discover, with the option request option to the DHCP v6 server, stateful DHCP v6 server, to say that. And then it advertises. All right. So in this case, we have the prefix and the DNS information option. Remember, you can get everything except your default gateway from a stateful, DHCP v6 server. Now, remember, I did the neighbor solicitation, router solicitation, router advertisement. In the router advertisement message, I was informed to use, and the M flag was on, sorry, meaning I should contact a stateful DHCP v6 server. And I sent the solicit to the server, information request option, and then the server responded. And now I am requesting. Okay. I sent a solicit. The server responded with an advertise with the prefix and the DNS information, and now I'm requesting for that. It's almost like V4, although I think if I remember that like 13 different messages, but this is the shorter form. Depending on the scenario, to change. Okay, so and then when the server receives the reply, it sends. The request. It sends the reply, and then you can configure yourself with the address. All right. So it's the solicit, advertise, request, and reply. All right. You can even, there's a rapid commit option where you can shorten it even to messages. All right. Where it's just solicit and reply. End of story. All right. All right. Let us quickly go. Let's start a quiz. Let me see how many of us are here. I think this is the last question. Sorry. Okay, for the 7 players. While we're there, let me see if this one is 60 players. Let me see how many of us are still here. 84. So I start the quiz. So the question is, what is the main drawback of using Slack compared to DHCPv6? Maybe I should have done that demo before this. We have about 15 more seconds. Yes. Actually, I was trying to show you that demo. I salute you guys who got it correct, because you see if that worked, you'll have seen that we have, not as much control and tracking over when you have a stateless address auto configuration. That's Slack. But with DHCPv6, stateful DHCPv6, of course, you have more control. So I wouldn't be sure about increased complexity or higher bandwidth usage. Definitely not. And it's not slower either. Okay, so let me quickly see if this one is back online, and then we can. Otherwise, we just have to skip that. Let's see. All right, that works. All right, I don't know what happened to the router before, so but these are the different. I had to reboot it. These are the different options. So I was trying to configure Slack so that one of the PCs will receive a address via Slack. So you can see I have the IPv6 ND, that's network discovery, and this time around I just want to choose the prefix, which is this one here, prefix information. And then it's asking me to type the prefix. So I put food the last time, BB8, what was it again? Food, yeah. :1, ::, /64. And then you can see here, I put the no auto config. You can so you have the option of valid lifetime in seconds, infinite auto config, off link router address. So this time around, I want to put the valid lifetime. So I'm going to put 80,000 seconds. And it's asking me for the preferred lifetime of the prefix. I'll put 20,000 seconds, just a test. I can say off link. Remember the L flag. That means I want to switch on the L flag, all right, for the route advertisement. But in this case, I can also press enter that I want to send out this prefix, food, :1, because after this session, I'm going for dinner. So let's see. And to be double sure, let's put the no IPv6. ND, press route advertisement, enter. Hmm. I'm sorry, nothing. Oh, that's a shame. All right, so let us configure. Let us continue with the presentation. I really wanted to show you how it works so that you will see that particular question where you have to select that it has less control over where the gremlins came to feast. Okay. Interesting. And our PowerPoint is not responding. I want to look at the quiz leaderboard. We know who's the top one before we have the final. Okay, finally. So let's see who's top here. What happened to Wesley? Okay. Yay, Matthew, eh? He's become very famous here now. All right. So I think that's the last quiz, but not the last thing. Just quickly, we'll finish up now. So the stateless IPv6, how it works. Same thing again, you send the router solicitation. A node that is just booted up has the address configuration. We do that. And then we send a corresponding router advertisement. Now, in this case, remember, the O flag means other configuration is on. That's one. The A flag means you should use Slack. The status address auto configuration, the one I couldn't show you right now, means the node should generate its whether temporary address and global address from that prefix. It's a /64, so it's going to automatically generate the interface identifier. So, but the other config says, yeah, you get an IPv6 address, but go and get your remaining configuration parameters, network configuration parameters from a stateless DHCPv6 server, which is usually the DNS stuff. So you do this time around again, it's a request, but this time is a info request. All right. Let's do that again. Sorry. Because if it's the stateful DHCP server, it's a request. But this time around, they're doing info request. All right. Because it's just other information request. And this time around, the DHCPv6 server responds with the DNS server address. All right. And then you configure that. So the address you got was from the prefix within the route advertisement. All right, and then the DNS server address you got was from the stateless DHCPv6 server, which I said is stateless because it's the same information to everybody on the node. All right. And then finally, we look at how prefix delegation works. All right. Just a quick animation. So we provision the WAN address and DNS. Remember when I started the section, what you need for in prefix delegation, you need an IP address, you need DNS also. All right. And then you send a solicit message. This time around, the option is for prefix delegation. All right. And then the DHCP v6 server, stateful, will advertise. We send you DHCP v6. And then you now make a request. It's time for a prefix. Now, now we use 60 here, but I've seen other places use 56 because you get to use 256 /64. So what happens is that, at least in the lab scenario, or what we tried to show you before, is that this router, the CPE, is going to take this /60. Let me the /60 because this is a prefix. It's not the address. Okay. Now it can subnet it. This can subnet it. So what it will do is going to take this 60 and break it to what to raise power for 16/64, for example, and send router advertisements outside this LAN facing interfaces with those prefixes in them. Okay. So it's basically when you delegate a prefix, it's like you delegating the work of you know the ISP to the home. Okay, so you get a prefix. Usually it's a 56. Oh, that's the recommended practice. So you're going to get with that one, you're going to get 256 slash 64s, which the CPE is going to subnet. Slash 64s on the interface. I remember Bashir said on Wednesday, use a slash 64 VLANs on your interface. It doesn't matter. It's not a waste. All right. So this is our DHCP-v6 prefix delegation. All right. So wow, almost at the 2 hour mark. So at this space, we're going to stop. Unfortunately, I couldn't show you. I really wanted to show you the Slack thing, how it works. So I couldn't show you that. It would have been longer than this. So in that case, let us take some questions, if there are any.
So there was a question from Anonymous Akende. What's the name of the terminal platform you are right?
Okay. It's I think it's called Temius or something. Yeah. I like it because it highlights numbers. I don't have to look for an IP address or whatever. It's easy to do that. I don't know if I have the Q&A open here.
So the other one is from Khalid. How do you check for the preferred lifetime and the valid lifetime?
Yeah, so if if this simulation worked or emulation worked, what I configured there, I mean your operating system will say we should do an IPA on Linux, for example, to show you that prefix that was automatically configured, and below it you see both the preferred and the valid and preferred lifetime. The valid lifetime comes first. Okay. So I don't know what the command is on Windows, but for Linux I know. So you can see it on the operating system.
Yes.
No, go on. So for example here, see valid, it says forever because I manually configured this one and they preferred it forever also. But if it were generated by Slack, you will have seen numbers there. The ones I configured on the router advertisement before it went out. So Richard Gibbs, I see that, yeah, we're not, yeah, so if you're in the top 5 last week or today, I mean, you can't be there more than once. So we're going to give room for other people that are below that to move to the top. Okay. Okay, I don't see any questions. Is it because it's a Friday?
Anonymous attended the name of that your terminal. You said it was Tamias or something. You can type it if you have the exact name. Okay, Tamias.
Tamius, yes. Yeah, it's easy for me to call it terminal or something if you look at it properly. It's Tamius. Okay, so let's see. All right, then. If there are no questions, I don't know if it's a Friday, like I said, let us take the survey. I have some feedback from you. So in this case, let's see. So what you have on your screen is, yeah, you can go to the URL. So it's bit.ly/ls, small ls, not I, ls-3-27-09. That's the date of today. Live session 3, 2709. Okay. And then you can use the QR code if you want to use your phone. Just a quick survey, like I always say. Let's see. Check how many we have there. Let's check a number and then we know which stuff. Okay, we have 49 completions. We are 76 here. Just a few more. One. Okay, I think that's enough. Let me see. So we are going to spin the wheel. Let's see. And entries do we have here? Okay. Just double checking to see if all your names are there. Let's have a blank window here. All right, so we have all 77 entries. Excuse me. So we want to select the 2 lucky winners now. Second. Yeah, so let us spin. Just when your name comes up, you just after the confetti and all that good stuff, let me know or let us know if you are here. All right, let's do this. Sorry. Please, Moyo, are you here? I see a hand raised. Let's see. There you go. Thank you. 1 second. I have to capture that. We'll remove your name. And then the second lucky winner now. In 3, 2, 1. Hey, Charles, I think I've seen you before. You were a winner last week. Yeah, okay. All right, so we have to spin that one again. Sorry. Yes, it was. I saw it. So, yes, Charles, you were part of the top 3, so you cannot get the wheel of names, yeah? So, is Jacob in the... Yes, you are. Thank you very much. All right. So, we've captured that. So, all right. If we don't have any other questions, I don't know what Patricia is saying there. I don't know. That's really funny. So, help is good stuff, though. So thank you very much. I'm sorry. I really wanted to show you, the way the networking of the heart of IPv6, because we do say you should not filter ICMPv6 messages on your network, otherwise you break IPv6. And I wanted to show you exactly why. But like I said, the gremlins came into my setup, and I know they run the whole thing, but it is what it is. So with that said, I would like to thank you all again for coming to this live session. Let me switch back to the slide. Coming back to the live session, the video will be made available to you as usual. Maybe I might cheat and put that stuff for you there as a bonus at the end, how it works. And then, yeah, and you'll get the slides in PDF format like as usual. You might get it on Saturday though. All right. So, but we'll see what we can do to get for you to get it today. But with that said, I would like to thank you all for coming again. It's always a good thing to see the registration numbers going up for an upcoming live session. It shows we appreciate your interest, and it shows that what we are doing, it's worth it. So we thank you. I thank you again for that. So with all that said, I thank you all, and I wish you all a very, very, very lovely weekend, and I will see you all on Wednesday. So again, the email is going to have that calendar. You have the calendar already anyway, but you have the date and registrations for the one on Wednesday, which is going to be implement IPv6 routing. All right. All right, then. You take care. And Luis Moyo, congratulations. And you take care then. Bye, all.